Okay, I'm on page 74 of your textbook. I'm gonna do exponential functions. So with exponential functions, there's the general form. Now we're gonna talk about the effects of the other letters. Sorry about that. So we already know what this Q is, what this P is. Remember, this Q is the vertical shift, that is the up and down, while this P is the horizontal shift, that is left and right, where plus P means to the left, then minus P means to the right, and so on. Now we're going to talk about this too quick, but then the important ones are P and Q. Now with A, let's start with A. For A positive and for A negative, that is the number that's here. So if that number is positive, we're going to draw a graph above the asymptote. So you'll have a dotted line, and then the graph will be above the dotted line, as you can see with both of them. But then with the negative one, the graph is below the dotted line. That is the effect of A. For B, look at it this way. So for B, if B is bigger than 1, the graph starts being close to the asymptote and goes away. So it starts being close to this line and then goes away. Being close, goes away. But with B being between 0 and 1, that is all of these options and more, it starts being away and then moves closer, away, closer. But with sketching, you don't necessarily need to remember them and all that. You can still sketch it without, even though they're still important. Okay, let's just go through. I'll skip the shape. Now again, when you have y equals to a, b, x plus p plus q, let's start with the asymptote. The asymptote will always be y equal to q. That is the number that's here. So that's where the dotted line is. When I add the number, this number on this number. So y equals to q will always be asymptote. The exosymmetry is just a line that cuts it in the middle. This one it doesn't have it. With the parabola, the line is like in the middle like this. Here we don't have it. So here, no, x is symmetry. Domain will always be x element of real numbers for exponential. Range will depend on whether you drew the graph above or below. If you drew it above, the range is this, because dotted line and it's above, that means y is bigger than q. This is q, so y is bigger than q because it's above q. If you draw it below the dotted line, y is smaller than q. That's page 75 of your textbook. So yeah, asymptote, the range, the domain, important. Now let's sketch it. So to sketch it, just like with other graphs, you just need in this case asymptote, dotted line. Just need to know where the dotted line is, and then you just find your intercepts. And then if necessary, one more point. That's that one where you choose -1 or 1 is x, and then you find the y if necessary. So in this case, let's sketch it. Asymptote is here. Dotted line, when you're drawing it, you're going to go to -2 and dotted line there. So you just need to know whether it's above or below. To find that, that's the asymptote. That means y equals -2. Intercepts. To find intercepts, you just, again, x-intercept or intercept. Let's start with the x-intercept. That is y is equal to 0. That means you put 0 this side. you're gonna move this 2 to the other side. You're gonna have 2 x plus 2. Here it's 1. The bases are the same. Laws of exponents since you drop the exponent, so 1 equals to x plus 2, and then you solve, move the 2 to the other side, x equals negative 1. As coordinates, negative 1 is to 0. So let me immediately plot it. So x is negative 1, so it's here. So as you can see, it's above. And then try to find also the y-intercept where x is 0. Did they find that here? Yes, y-intercept where x is 0, then you put 0 there, you get 2. So that means this is 0 is to 2. X is 0, 1, 2, the y is 2, so it's there. So that means it's going to be like that. Then you get your 3 marks. Let's go to another one. On this one, they gave you the equation. Sketch the graph. Y equals to. Gave you the sketch. The equation and said the y is equals to minus 3 into 1 over 3 or 1 over 2. So exponent x plus 3. In this case, immediately you can see that dotted line will be on positive 3. That means if we start drawing our Cartesian plane on 3, 1, 2, 3, dotted line will be there because of this number. That is y equals to 3. Okay, now you just need to find the intercepts. Find the intercept, you get that y-intercept, you put 0 there. This is this one. Y-intercept, that is x is 0, put 0 there. Solve, you get 0 again, that means 0 is to 0. You also try to find the x-intercept. You're going to see as well where y is 0. You're going to see that when you solve this, you're also going to get 0 because this will be divided by negative 3. It's going to be 1 is equal to 1 over 2x. Then 1 over 2, 0 equals to 1 over 2x. So this one is this one. So I just wanted to have the same base. So to do that, I just raise it to exponent 0. Anything to exponent 0, it's back to 1. So you can do that with any number as long as you just get them to be the same. That means x is 0. So also it's 0 is to 0. In this case, you're only going to have 1 point, 0 is to 0. Both x and y-intercept are here. That's where you choose 1 or negative 1 for another point so that you see how it goes. Because it can either go like that or it goes like that. So to find an accurate one, you just take x. Let's take here what did they take? They took both actually. They took x equals negative 1 and x equals 1. You can take 1 and see what happens. So let's say you took negative 1, then you plug it where you see x, then you're going to get negative 3. That means negative 1 will go with negative 3. That means when you're on negative 1, the y is 1, 2, 3. The y is here. That means the graph has to go like that. That's it. That's this one. Again, you can do both x, negative 1 and positive 1. Otherwise, even 1 is just fine. Just one of them is just fine. So the next part is finding the equation. See the time? 9 minutes, okay? I think I'll stop it. I'll do another one for finding the equation. Let me stop it.